Right, this is how you use the S&P lag time in order to figure out the distance a station is from the epicenter of an earthquake. So, if you look at the example seismogram that's on the screen, you'll see that the seismogram starts at 6:30 a.m. and it starts with just the regular background noise, the regular movements that we have of the plates on Earth. Then at 6:35, right here, you see the first jump happens when the initial or the arrival of the P waves has begun. And so at 6:35, the earthquake has hit this station. Then you'll see that it calms down, goes back to background noise until the second jump happens, which is when the S waves arrive. If we trace that down, that happened at 6:39. So the difference between 6:39 and 6:35 is a total of 4 minutes. So that is the lag time that we have between the S and P wave arrivals is again 4 minutes. That's going to be enough information for us to figure out the distance the station is from the epicenter. So we're going to use this graph here to figure out what that distance could be, and we're going to use a shape in order to help us trace that out. So I take the shape and I make sure that the bottom left corner is at the 0 mark. So this bottom left corner right here at 0, and I change the size of the shape until the top of it lines up with 4. All right, so that's a little bit short, so make that a little bit taller. And then once we have it as exactly the right size, so from 0 to 4, we're going to use this side of the shape and we're going to do what's called the wedge method, where we take this bottom left corner and we trace it along the P wave until the bottom left corner's on the P wave line and the top left corner is on the S wave. So if I trace up here, we can see that now we have it lined up exactly where we want it. So the bottom corner is on the red line, the top corner is touching the blue line. If we trace that down, it goes down to exactly 3,000 kilometers. And now every line is 200 kilometers, but it's on that darker 3,000 kilometer line. So that is what I'm going to add to my map. So if my station is, let's say my station is in Chicago, okay? Then I'm going to change that to Chicago as my station name. Make sure that my latitude and longitude match up with what it says in the lab. And now I know my distance is exactly 3,000. So I'm going to change that to 3,000, hit enter, and my circle becomes the correct size. Now, if I zoom out, I know that the epicenter of the earthquake is somewhere on the edge of this circle. I need to know the other two stations in order to triangulate where the epicenter is. So once I get those lag time informations from the different seismographs, then I'll be able to do this method again using the same shape and figure out the distances for each of those stations. Where each of those circles cross is where the epicenter of the earthquake happened and where we can send help.